Well, here we are with box sequence 3, and I think this is a Harrier CBX, and I wouldn't be surprised if I can't do this today and actually get a second CB in this week. I'd like to move on to number 4. Right. Okay, how do I open this? I don't have a knife on here. Well, we've got a sharp screwdriver. Got their address there. Hey! I was wondering how it was packed in this box, now I know. Well, that looks in nice condition. Comes with a standard replacement coffin mic. It comes with the side bobbles, which I must remember to put back with it because accessories like that are easily missed. Yeah, look at that. It's lovely, isn't it? Wow. So we'll see what it's doing. Now this customer has got one of those Cobra 29 swish looking sets that actually don't work very well at all. And this will be a huge improvement on that. Right. If you can hear background noise of big engines, this farm machinery like right next to the field next to me, we have to appreciate I've got fields on 3 sides and woods, got a bit of a lane and then woods on the other side, so middle of nowhere. Best way to be. Nearest neighbour about 3/4 of a mile away. Okay, power it up. So we'll make sure we're in full tone. Yep, that looks about right. Okay, well for some reason I haven't got my other camera on. It is on, but the converter box which turns the high band signal into HDMI doesn't appear to be doing anything. Okay, so let's see what it's doing. So we'll start off in the 3 watts on the 3 watt scale, so it should be full scale deflection, and it's only just, I would say it's doing 3 watts. So we'll just pop that onto the 30 watt scale. It says about 2.8 watts, so yes, that needs to come up. On low power it should be 400 milliwatts, and it's doing 90 milliwatts. So let's have a look. So it's we'll give it the benefit of the doubt and say it's 2.9 watts. Let's look at deviation. While, oh my goodness, it's 5. It's great, and you can hear somebody on 3 channels. And let's set the signal generator up. First of all, we'll see how on frequency it is. So we're looking at 2779.125, 2779.087. So it wants pulling up, but it's not out of spec. So to be fair, I'm going to set the receive the same, so that we are actually going to not be checking the receiver out off frequency. So 7, I've just set that 7.9 instead of 125. We'll set that the same. So that's now just as off frequency. We can hear that coming through. In fact, it's coming through very well. Let's plug in the thingy here. Extension speaker into the test instruments. Switch over to the synad meter. Oh, that's lovely, that. So you see that's at 12 on the meter. And if I show you the attenuator, if there's enough light, it's actually at 0.3. So it well exceeds what it should do on receive. So now we'll put the frequency correct on here, which will probably throw it out. It hasn't, to be honest. It's near enough. Right, we'll get this opened up and we'll make a start on doing some service work. So as long as it hasn't been messed with when we get inside, it should be plain sailing. I'm still waiting for floorboards for our other building, which stops me getting on properly with the organ. So I can just fit 1 or 2 things like this in a bit whilst that's happening. Lid has no showing of cigarettes. Radio shows no signs of being messed with. It's absolutely, I mean, considering that's 40 years old, wow. I mean, there's no capacitors showing their age, nothing. What we'll do, we'll just start and get that frequency on. So 2779.125 is what we want. very slightly high, then it's got room to drop, which is what they do. So next thing we really need to do is to set the VCO, which I recall we start on channel 40 with. I have to look this up every time, having a memory like a sieve. I've got a really nice copy of this manual, and I'll still end up using the tatty one. So we start off on receive, channel 40. And we're looking, I'll just put the negative prod onto something which is at zero potential rather than the chassis which is floating. And we're looking for the far side of that resistor, 3.86 volts, and it's supposed to be 4, so it really is, you know, it doesn't need adjusting, but I will just for the video. 3.86, do that coil, especially if we can get the prod on. .95, that'll do me. We'll set the radio into transmit. It's supposed to be 4 again. So we'll do the red trimmer at the back. I'll probably never get it back to even as good as it was. .88 will do me. Back to receive, 3.95. Back to transmit, 3.89. Then we go to channel 1, and it should be between 1.8 and 2.2 volts. That's receive, that's transmit. Jobs are good, and it didn't need adjusting, but just for the hell of it, it's absolutely now spot on. We'll just pop through the, now go on high power. I was on low power. So we just need to tune. Well, we've actually got 3.1 watts now. Oh, but we're on channel 1, which shows me we're out of balance, doesn't it? Okay, 3.8 watts. So we'll just go through these. They're set right. Really we want the green tool, but we never seem to be able to find the green tool. Let's see whether we can get the blue one to fit. We can. Maximum. That's at maximum. That's now at maximum. Maximum, just make sure that is. We've got to be quick at this, because what we don't want to do is to end up thrashing the transmitter now that it's doing 4.6 watts. So, I again can never remember this procedure. So that's L4, L8, L9. So now we need to rotate L4 counterclockwise for 4.4 volts. So just pop that down a fraction. 4.4 it is. And then they want you to do 9 counterclockwise to get 3.8 watts. Well, we are going to set it for 4 watts because unlike the factory, we haven't got to get it through customs. So there we are, spot on the 4 watts. Mind you, radio's drawing 1.19 amps, which is quite hefty for one of these. So now we'll go to channel 40, see how many watts it's doing there. It's doing 4.0 something, and on channel 1 it's doing 4.0 something, and on channel 20 it's doing 4 spot on. So we've balanced that absolutely perfectly. So I'm very pleased about that. The customer now has a full 4 watt radio instead of 2.9. And it doesn't make that much difference, but it makes some difference. So while we're at the transmitter, we'll do the deviation. So I want the mic... right. Okay. Oh, it's so tarnished, I thought it was broken. So I want the mic gain one to be in its central position. I'll just change glasses. This is really not how they're supposed to be. That wants to be in the central position. And then we want that adjusting for the correct deviation. Let's try it about there. Wallow. 1, 2, 1, 2. Wallow. Now it's actually too low. So I've gone from one extreme to the other. Let's try it at that point. 1, 2, 1, 2. Wallow. That's absolutely spot on. So we don't want to ever to exceed 2.5, but we want the average to be around 2.2, which it now is. So on transmit, we want the meter to read 4, and it reads over 4, so we'll adjust that. Just like that, beautiful. And then on low power, we want the radio to do 0.4 of a watt, 400 milliwatts, because low power is a 10 decibel attenuator, and it's doing 1. I suspect that's dirty actually, because they often are. We'll just waggle it around a bit. 400 milliwatts, spot on. Good. Well, that covers the transmitter. So I'm going to go, I'll leave that on. We're going to go for a lunch break. Sure, I heard the microwave go ping. And we'll come back and do the receiver. Okay, so moving over to the receiver, we'll start by looking at the detector on the oscilloscope. So we've got an equivalent to S9, which is 100 microvolts in the UK for, start that again. So showing on the oscilloscope, it's just across the loudspeaker, there's nothing clever about it, and we are looking at an S9 equivalent of 100 microvolts from the signal generator. So we need to make sure the detector is spot on. And we also need to make sure we've got the right tool to do it. So the detector coil is this one lurking down here. think that was pretty spot on as it was. So we'll drop the attenuator and we'll look at this on the cyanide meter. So we usually have it about 4 dB, which is about there. We'll run through the front end. Well, I'm already amazed that I've been able to alter anything, because it was working so well when we tested it. Put a bigger signal on for some of these. And there's one under this wiring which usually gets missed. Okay, let's go back to 4 dB, just see if we can get a fraction more. No, I think we're there. So we've not improved, we've not got any more sensitivity than as it came. It's still doing 0.3 of microvolt for 12 dB cyanide, but I think we've improved it at 20. It's 1 microvolt for 20 dB cyanide, and we'll look, it is 0. I'll just do the 12. Sorry, we've done the 12. We'll do the 10. It's 0.9 for 10 dB cyanide. We may have gained some. We may. It's marginal. But in the quality, we have gained some. Okay. So we thought the receiver was going to be pretty spot on, and it was. So we'll put S9 on the test set once again, and may as well put this onto the attenuator, and we need to just make sure the meter says S9, which I can't see with these glasses, so we'll change it to those. You know, it's about spot on, that. So that's 9, turn the signal down and the meter goes down, turn it up, it goes up. So that's excellent. Now the squelch. So I'm going to turn the squelch to full. And now we're at 30 microvolts. I want the squelch to come in at 100 microvolts. And it doesn't, so I just need to adjust that. Drop the attenuator, and back, and back. That's now spot on in my mind. So we'll turn the signal generator to standby, and we'll set the squelch to threshold. Switch the signal generator back on and see when it comes in. It comes in 0.8 microvolt, drops off 0.75 microvolt. Squelch isn't the best thing on these radios, but it is competent. So we have gone through everything on this, and it's working an absolute treat. And the customer's going to enjoy this so much more than their swish-looking modern Cobra 29. That's an excellent result. We'll be on to Scratchy Corner with this, but we'll get it put together in the meantime. It's quite a short wire on this one. It's funny how it differs. Just need to check it works on this internal speaker. And the answer is it does. Right, we'll switch it off, put the screws in, and then we'll put it on the aerial instead of the test equipment. Right, we're plugged into the roof area, which people ask me this, and I do say sometimes, it's an Antron 99 Type F fiberglass 18-foot end-fed aerial. This building is a single-storey building, and it's mounted a couple of feet above gutter level, so it's not that high, and it's done like, it's not the one with the ground plane kit either, it's the ordinary one. We do everything here not to be elitist. Right, so let's go through. 1.9, oh, it helps if we're on high power. 1.9 Roger. Bit of something there, about 35 miles away. That's some farmers who choose to use Channel 9. Okay, so we'll leave it at that, and we'll do an on-the-air test later on, and I've no doubt it'll work fine round Scratchy Corner. So that's a really nice radio, Harrier CBX from 1981, using the Cybernet 134 chassis. Thank you for watching.